Hello and welcome. So far, we have discussed about what is regression all about. We have tried to discuss first linear regression, and we know that we can extrapolate that knowledge into other forms of regression like exponential regression or logarithmic regression or polynomial regression, etc. Now, we come to a very powerful algorithm called random forest algorithm. Random forest algorithm was created by Bremen, and it was mainly for classification problems. However, random forest algorithm is also possible to use for regression, and it is very powerful and very popular as well. So in this video, we will go through the random forest algorithm. I will try not to get into any kind of mathematics of the algorithm. Instead, I will try to explain it in as simple a language as possible, and we will only focus on what the algorithm does. So let's get started. Before we can discuss random forest algorithm, we need to understand a few things. So first we start with understanding what are decision trees. Now to understand decision trees, suppose that we have a data like this where I have 5 variables. This is A, B, C, D and E. So these are my independent variables. Based on these independent variables, I want to make a prediction for the dependent variable, that is f. Supposing this is my problem. Now, one of the ways to solve this problem is, we know that we can do it through linear regression or quadratic regression, etc. But one of the ways to solve this problem is that we can try to make a decision tree. Now, what the decision tree does is that we will start with a node, that is a root node, and then we will find out, based on these parameters, can we make a branching of the data. So I will make a branch. Let's say that I say that if a is greater than 2, then create a branch here. So all the data where a is greater than 2 will fall under this branch, and I will make another branch which I will say whether c is less than 5. So supposing I make this branch. Now these branches are not made arbitrarily. There is a logic to make these branches. The logic is simple. What we do is that we take all the data and we find out, if we make this particular branch, then whether the sum of square error, that is SSC, we know this, for the two branches in this case that we have made, is the sum of square error of the branch 1 and the branch 2 put together, is it less than the sum of square error of the total data. So we try to minimize this sum of square error for each branch that we make, and try to see that whether the sum total of the sum of square errors of these decision to make this branching, whether it is minimizing itself or not. Now based on this fact that we are going to minimize the sum of square errors, we will create these branches. These branches that we have created, these are known as splits. So we are basically splitting the data. We are splitting the data, and we so under this, now we have one set of data, and under this we have one set of data. The amount of data in both the splits may be different. Now after we have split the data, let's say we stop at this point itself. After having split the data, now we have a data here and now we have a data here. What I will do is that I will make a linear regression out of this data and a linear regression out of this data. Based on that linear regression, I will try to make a prediction for the new data what is coming in, and then I will take the average of both the predictions what is made from both the branches, and that average will be the resultant of my regression using the decision tree. So I make splits here, and then in each split I will create a linear regression model, and then I will take the average of the linear regression model, which will be the resultant, which will be the prediction for the variable f. So this is what is decision tree. Now in decision tree, we do not stop here. What we do is that, supposing we have made this split and we find that if we make a further split, then the SSC is reducing further, so we can make further splits. So we can keep on splitting, and this is a recursive process till we can reach a point where we can split no further. Let's say that we have set a criteria that the sample size under each split should be at least 20. So we should have at least 20 data points after having split. So once we reach that point, we may stop splitting. Or supposing we keep on splitting and find that after a certain point, the splitting is causing the SSE to go up. That is the sum of square errors to go up. In that case, we can stop splitting and then we can remove some of the splits. When we remove the splits, it is known as pruning. So we can prune our tree and make it smaller and see and come to the point where we have the best result in terms of the least SSE. Now this pruning and splitting both are mathematical operations and this follows deep mathematics. I will not discuss that mathematics here. Instead, I hope you have got the idea what is the decision tree all about and how it can be used for regression. Decision trees are good for making regression models. However, they have got some problems. Now, the problems I will not discuss in details, but basically it tends to be that if the new values are inserted into the decision trees, then it can cause the decision tree to become unstable. So, researchers further did study and came out with another technique which is known as bagging. Now, let's go back to our original data that let's say we have this data where we have these variables A, B, C, D, and E. So these are our independent variables, and based on this independent variables, we want to make a prediction for a dependent variable, that is F. So this is our problem where we want to regress. So supposing now we understood decision tree in the previous slide. Now what we do is that researchers found that instead of making a single decision tree, if you make multiple number of decision trees and then try to find the linear model out of that, then it gives a better result. So what was done was that this decision, after this data was taken and at random some samples were taken out and one set was formed. This set is known as S1, and then another set was formed from this data where data at random was taken out, and the data was taken out by replacement. That is, I can use the same data in two sets. So I form another set called S2. So now we have two sets. Let's say I form a third set also. So I form another set from this data where I have the random sample from this data where I get a set S3. Now at random a number of sets were formed. These are in each set. Then what was done was that the decision tree was implemented. So I make a decision tree for each set and I get, in this case, if I have made 3 sets, I will get 3 decision trees. So once I have my decision trees, I will use my decision trees, the individual decision trees, to create my regression model and generate the prediction. After I have generated the prediction from the 3 decision trees, I will take the average of the value from the 3 decision trees and that will be the resultant of my regression. So it was found that this technique produces much better prediction as compared to a single decision tree. Now, this technique of creating a random split of the data and forming decision trees in each sample and then averaging the value of all the decision trees to find the ultimate result is known as bagging. So this is what is the technique of bagging. Now, bagging technique is coming under the class of machine learning models which is known as ensembles. This is an ensemble basically because what we are doing here is that we are making multiple models. So this is one model, this is one model, this is one model. I can have multiple number of models and then each model is creating their own prediction and then I am taking this average of all the models put together to find my ultimate result. So these are known as ensembles. The ensembles have been found to be giving much better result as compared to a single model. So bagging is a technique which is an ensemble model which gives better results as compared to decision trees. Bagging was a good model. However, researchers again found that it also had some deficiencies. And then Bremen came out with an idea in 2001, which he called the random forest. So what is random forest? Let us discuss that. Supposing we take our same data. We have this data where we have this independent variables A, B, C, D, E. So let us name that A, B, C, D, and E, and we have to make a prediction for the dependent variable, which is F. So these are our independent variables A, B, C, D, E, and the dependent variable is F. So now we understood bagging, where we are taking random samples of the data and creating decision trees out of each of the samples. So this is what we were doing in bagging. Now random sample goes one step further. What it does is that it creates multiple samples. So it is going to create multiple samples just like bagging was doing. So random forest is also a decision tree model. So this is the sample S1, this is the sample S2, and this is the sample S3, and so on. So we have created random samples. In these samples, we're going to have the randomly selected data from the whole data set what we have got. Apart from that, what we will also do is that we will select at random the features which will be considered under each sample. So I may take in this sample the feature A and C, and at random I take in this sample the features A and D, and here I may take B and E. So this selection, I will make the selection of features in each sample also at random. Now how many features will get into each sample, that also can be fixed, and we can parameterize that, and we can tune our model based on that parameter. Now how many parameters get into a particular sample in random forest algorithm is normally referred to by the variable called mtry. Now this is the variable, this is a hyperparameter for random forest algorithm which can be tuned. So mtry is the variable. Normally we set mtry is equal to total number of independent variables that we have divided by 3. This is seen to give the best possible result. So if we have in this case 5 independent variables, so if I take 5 by 3, which is coming out to 1.6 something, so it is good that I give 2 variables as my mtry. So if I do that, then random sample will take at random 2 variables in each sample, and under those 2 variables it will take data at random from the full data set. So we will have random data from the full data set. Now on these samples that has been collected, the linear regression model will be created, and the resultant will be a decision tree will be created, and this decision tree will produce the result of the regression by its algorithm. After having found the result from the decision tree of each of the individual decision trees, this value will be averaged to find out the result of the prediction what the random forest algorithm will produce. So this is the whole idea behind random forest algorithm. Now this algorithm is found to produce very good results in terms of finding regression predictions. Also, this is very largely used in classification, where it is very powerful. We will not discuss classification right now as we are discussing regression, but I hope you have got the idea behind what is random forest algorithm all about.